Devjyoti.
Yeah, how are you, Debjyoti?
My written exam is good, but PS in PSA, few questions are wrong in that exam time. It is not
Am I not audible?
audible. Yes, audible.
Okay. Okay. Okay, Dobijit. Yeah, tell me about yourself.
I am a Devjyoti Mondol. I am a student of statistics honors in Ashutosh College, Kolkata. Recently, I have a student in 6 semesters in graduation, and my schooling was completed from Jadavpur Vidyapit, Kolkata, from science background.
Okay. Okay. And you've done your graduation in statistics.
Can you repeat it?
You have done your graduation in statistics, right?
Statistics, BSc in statistics honors.
Okay. Okay. So, which topic are you interested in mathematics?
On linear algebra.
Okay. So, shall I start, Raghav?
Yes, sir.
Yeah.
Sure, sir,
Okay.
sure, please.
Yeah. Okay. Yeah. Fine. Yeah. Okay. So, yeah, definition of a nilpotent matrix. Can you tell me, Dabijoti?
Let A is a matrix. It is a square matrix, and A square is equal to 0. Then it is called a nilpotent matrix. A is a
Okay.
matrix n cross n. Then A square is equal to 0. Then it is a nilpotent matrix. And A to the power p is equal to 0. When p greater than 1, it is also a nilpotent matrix.
Okay, I don't know what you wrote in the board. Somewhere you wrote a square equal to 0, then you wrote a to the power p equal to 0 and p greater than 1. What about zero matrix then? Zero matrix is nilpotent or not?
A mat Here A matrix is nilpotent.
So your definition is a matrix
A
is nilpotent if a square equal to 0, right?
can satisfy, then A is an important matrix.
Okay. Okay, write a matrix. 3 cross 3 is 0. Yeah, 0 0 1 0 0 0 0 0 0. Okay, at the position of A12, write 1, A12. Ah, yeah, it's 1. Write 1. Write 1 instead of 0. Not here. The second one. A12 entry. Ah, yeah, G. You don't know what is A12? A12 entry in the matrix
Sorry.
and A23 also. Yes. Okay, there are, okay, you wrote two matrices. So are they nilpotent or not?
First, A matrix is nilpotent, and then second matrix is not nilpotent because A13 element becomes 1. So does not satisfy to null matrix.
Okay. What are the eigenvalues of an nilpotent matrices?
Sir, can you repeat it?
What are the eigenvalues of nilpotent matrix?
Because my phone calling is coming, so internet connection is.
Okay.
Hello.
Okay. What are the eigenvalues of a nilpotent matrix?
Hello.
Yeah, Raghu, please help me.
Am I audible, Devjyoti?
Yes, sir.
Sir, Divakar, please proceed.
Yeah, Devjot,
Yes, sir.
am I audible now?
Yes, sir.
Okay. You know what are the eigenvalues of a nilpotent matrix?
Eigenvalues Newport matrix all 0.
All are zero. So the eigenvalues of a second matrix, yeah. So you wrote a two matrices, right? So what are the eigenvalues of a second matrix?
Eigenvalues. Eigenvalues. All are 0.
So don't you think it is nilpotent then? Yes or no?
Yes, sir.
Then your definition was wrong then. Okay, okay. So do you know what vector space over a field is?
Vector space is x and y two elements from
Do
a
you know? Say yes or no. Do you know or no?
yes, sir.
Okay. Can you give an example of infinite dimensional vector space and finite dimensional vector space?
Yes, sir.
Yeah, please. Write on board. Okay. What is I?
I is integer set of integers.
Okay, if I take I equal to -1, then it's a set of integer, right? Xi belongs to. Oh, so you are taking. So the ordered pair belongs to what? I mean x1 comma x2, where it falls. The entries are okay, like Xi belongs to I. But what is the set then?
The set is infinite.
Are you sure it is a vector space? You know, vector space, we define vector space over a field.
Yes, sir.
What is field here?
Field is a set of integers.
So set of integer is a field. Are you sure?
Yes, sir.
Okay. What is rank? Rank. What is rank?
Rank a matrix. Rank is the no, of rank matrix A. Then rank of A is equal to dimensions of column space of A matrix is equal to dimensions of row space of A matrix.
What is dimension of row space then? How will you
Uh,
find? I mean, what is the tool?
Dimensions of row space of A matrix. It is a row vector of A matrix. Then a set of matrix A1 transpose call A2 call transpose dot AN call transpose. Then that here the number of linearly independent vector in this set, then the dimension is assume that the number of linearly independent vector in the set is k from the n vectors, then the dimension of this vector space is k.
You are not precise, Devajyoti. You are not precisely saying. Okay, what is linearly independent?
Linearly independent. I have n vectors x1 call, x2 call, xn call. Then lambda 1 into x1 call plus lambda 2 into x2 call plus lambda n into xn call is equal to 0. Here this equation satisfy. I can say that this set of vectors is linearly independent when all the lambda i's are 0. Then the condition is satisfied. But you can when you can tell the linearly dependent, then at least on lambda is not is equal to 0.
Okay. 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 Tell me something. I mean, another topic. I mean, are you confident in?
Stat for statistics.
No, no. From linear algebra.
Eigenvalue, eigenvectors.
What are the eigenvalues and eigenvectors? Yeah. Definition. Tell me the definition.
Eigenvalues is a square matrix a square matrix M cross M, then determinant of A minus lambda into In is equal to 0. Then you can a characteristics polynomials, which is a variable of lambda. Then it is solved of term of lambda. Then the roots of the polynomial is get. Then it is this root is called the matrix M's eigenvalues.
Okay. Can you write the definition when lambda is said to be an eigenvalue?
this is the characteristics polynomials of the matrix A. Then you solve the lambdas. You can get the n lambda 1, lambda 2 this similar way, lambda n roots. Then lambda 1, lambda 2, lambda n is the eigenvalue of a matrix.
Okay. So do you know if at least one eigenvalue is zero, then determinant of that matrix will be zero?
Yes, sir.
Can you prove?
Yes, sir.
Don't rub it. Write it again. Write it
Can
again.
you
Don't rub it. Write it again. A minus lambda n. Very good. Now prove that question. You have enough space on the board, right?
sir, is the last term a naught. It is a product. It is a term when the product of the all roots of the equation from polynomials concept. We can say that the a naught is the root product of the root lambda 1, lambda 2, dot lambda n. So here a lambda 1 is equal to 0. So a naught is equal to 0. So a n plus in lambda to the power n dot a n minus 1 lambda is equal to 0. Then if one common lambdas from the equations, then you can say that lambda is equal to 0.
Okay. Okay, you know why I denied to rub you the board? The hint is on the board. Okay. That determinant of a minus lambda n equals to 0. Put lambda equals to 0, then determinant will be 0. Okay. Okay, the idea is correct, but you should be more precise while speaking. Okay.
Okay, sir.
Okay, one last question. What is the rank nullity theorem?
Rank nullity theorem is the dimension of a null space of a nullity of a matrix. A matrix is m cross m. Then nullity of a matrix is null space of a dimension is equal to n minus n dimension of column space of A.
Okay. Okay. Thank you. Thank you, Jabaditya. I will give you feedback in the last. Yeah, Raghav.
Thank you, sir. Okay, Devjyoti, I'll be asking the probability part. We'll start with a basic probability question. Say you have a dice. So there are two players playing a game. You have a dice, and say player A and B. Player A starts the game, and to win he has to roll a number, and the probability of getting that number is P. Okay, and am I audible?
Sir, I cannot hear your voice properly.
Am I audible now?
Audible, but voice is down. It is not can hear me.
Now is it better?
Better, it is better than
Better
previous.
now?
Better.
Okay, so I'll repeat my question now. Say there are two players playing a game, person A and person B, and they roll a die. So the person A starts the game, he rolls the die first, and the probability of him winning is P. So to win, he has to roll a certain number, and the probability of getting that number is P. Now, if he gets that number, he wins the game. If not, he passes the die to player B. He again tries to roll the die, and if he gets that number, the probability again is P, and if he gets that number, he wins. Basically, if one person wins, the game stops. They do this back and forth If they win,
Sir,
if
I
one person,
cannot hear your voice.
uh, sir, can you confirm एक बार आवाज आ रहा है क्या?
Sir, can you leave, can I leave to in another? Can
Actually, you are not audible, both of you. I mean,
अच्छा, मुझे Devjyoti, I can hear you.
very low voice.
Okay, no worries. I'll ask a short question then. No worries. Say you have
Sir,
two.
can I leave again? Leave and join again?
Sure. I'll check my mic once.
ईयरफोन हटा के देखो तो एक बार, फिर शायद आए। ईयरफोन हटा के देखो, शायद अच्छा है।
अभी सर साफ नहीं आ रहा क्या?
मतलब उतना ज्यादा क्लियर नहीं आ रहा है भाई, मतलब आ रहा है, सही आ रहा है, बट मैं तो ध्यान से सुनना पड़ता है।
एक मिनट।
सर आप क्या ईयरफोन यूज कर रहे हो?
नहीं, मैं ईयरफोन यूज नहीं कर
हाँ
रहा हूँ।
वही प्रॉब्लम है, मैं भी जब नहीं कर रही थी ना आवाज लो आ रहा था। शायद ये जूम का ही कोई साउंड लेवल का कुछ
ओके
सेटिंग्स होगा।
ओके।
विदाउट ईयरफोन आवाज लो ही आता है, शायद दीपज्योति भी नहीं यूज कर रही है।
विशाल, तुमको
मैं
मेरा
कनेक्ट
आवाज आ
कर
रहा है?
लेता हूँ।
हाँ मेरे को तो ठीक ठाक आ रहा है।
ठीक है।
ओके, मैं कनेक्ट कर लूँ।
देवज्योति को भी मैं बोलता हूँ, ट्राई टू। देवज्योति, डू यू हैव अ ईयरफोन? ब्लूटूथ वाला ईयरफोन इफ यू हैव।
हाँ.
I think it would be better if you like connect with the
हाँ.
earphone, है ना? Do that please.
So you can start it. I connected my Bluetooth.
Okay. ठीक है, so I'll repeat the question, है ना? Am I audible अभी?
हाँ, audio.
ठीक है. So I'll repeat the same question. So two players are playing a game, person A and person B. Person A rolls a die first, and the probability of him winning is P. If he wins, the game stops. If not, he passes the die to person B, who again rolls the die, and the probability of person B winning is P. So at each point, the probability of winning is P. By back and forth, they roll the die. If one person wins, the game stops. So can you like calculate the probability of person A winning?
The person A rolling a die, the winning probability is P, and the probability of person B winning probability P.
Right. A person A starts the game, so he rolls the die first.
First A person is start.
Yes.
Then we start.
So if A rolls that number on the die, the one with probability P, he wins. So the game ends. If not, he gives the die to person B. Then person B rolls. Do you understand? So the way to win the game is you roll that number, the winning number. Say the number 6 is the winning number, and the probability of getting a 6 is P. Is the question clear?
No, sir, I not understand the question properly.
Okay, no worries. I'll ask some other question. It's okay. Maybe I'm not able to explain it. No worries. Say you have two events, A and B, and they are independent. Okay. Can you show that A and B complement will also be independent? Is that true? If A and B are independent, is A and B complement also independent?
Yes, A independent with B, then A complement and B is independent also.
Okay, can you prove that? Uh,
Sir,
I
it is
didn't.
clear about
Okay, the three lines on the top, that's it. Let me see. Hmm. We have proved that A complement and B are independent. Okay, fine. Say you have two random variables. You can erase this. So random variable x follows gamma distribution with parameters alpha 1 and beta. And independently, y follows gamma alpha 2 and beta.
alpha 2 comma beta.
Right. Okay. Now, can you show that x plus y and x over y are independent?
And x over y.
Right. Are independent. अच्छा, you have written this x plus y and x by y ka the what they follow. Can you derive this? I think when you are deriving this, you'll obtain the independence of these two.
It is called use the Jacobian transformation. So
Right.
um, x plus y here gamma alpha 1 plus alpha 2 comma beta. It is used for uniqueness property of MGF. So you can prove down with what x y y. I cannot remind to this Jacobian transformation at this moment.
Uh, okay. Let me help you. So, you know how you remember how we used to write it, like we write say x by y, you can call it u, and x plus y you can call it v. Then you transform it, so you write x in terms of u and v, y in terms of u and v.
It's,
Have you completely forgotten, or like you are not able to remember where to start?
Here's the Jacobian is not remanded. U is equal to V, then you can Jacobian u by dx, dy by dy, then matrix from a Jacobian mod Jacobian. But here at this moment Jacobian is not remained in mind. And I tried.
At least try something. Write u equals to x by y and v equals to x plus y. Try to do something.
Sir, I can remove the upper portion of the code.
Let me read once. Huh? Just 1 minute. Del x by del u would be v over 1 plus v, I think. Uh, but I think you're almost right. So I think you're almost right. So tell me, how would you proceed after that? Don't write it. After the Jacobian, what would you do?
Then you can can calculate the determinant to put these values,
Okay.
and you can mod the J called Jacobian.
Hmm.
Then you can join distributions of x comma y which is independent to separate them, product them.
Hmm.
Then you can replace by x and y in terms of u and v. Then you calculate, then you product the multiply the mod Jacobians, and then calculate the range from the this.
Okay. So where does the independence part get in? how do you say that U and V are independent?
U and V are these joint distributions are separately product
They
of the marginals of U and marginals of V.
right, so they can be factorized. So when you're able to factorize them, you say that they're independent, and the independent factors you get will be the distributions of U and V.
Hmm.
Right, so you should be confident. Matlab, you were able to do it on your own. You said that you don't remember Jacobian, but you did it. So don't don't say that you don't know. वहाँ पे just try doing it, and they'll guide you through it. Okay.
Yes, sir.
We don't have much time, so I'll ask one last question. Say you have two independent random variables x and y, where x is normal 0 sigma square and y is normal 0 sigma square again. X follows normal 0 sigma square, and independently y follows normal 0 sigma square. What does x over y follow?
First, x mod x sigma square is equal to x minus sigma follows normal 0, 1,
Okay.
and y root over sigma square is equal to y by sigma follows normal 0, 1.
Okay.
Then x by y is equal to x by sigma y by sigma. It is called Cauchy 0, 1.
Cauchy 0. That's correct. Okay, Devjyoti, that's all from my side. Now Dishari will ask the statistics. Thank you.
Thank you, sir.
Devjyoti, am I audible to you?
Yes, I'm audible.
Okay. Can you please drop the board? First tell me what's type 1 error and type 2 error.
In testing of hypothesis, type 1 errors is H not true, but I rejected the null hypothesis.
Can you write it in probability notation on the board?
Yes, ma'am.
Okay. Now type 2 error. So what is type 2 error in words without the probability thing? Just tell me in words.
Type 2 errors is H naught is H1 is alternative hypothesis is skeptic when
You're not audible. Can you say it again? Devjyoti, am I audible to you?
Voice cannot hear me.
राघव, वॉइस का प्रॉब्लम हो रहा है क्या?
नहीं, you are audible, Vishal.
Devjyoti, can you please check your internet connection or Bluetooth? I'll wait. Am I still not audible to you?
Voice is slow down. Cannot hear
Okay.
properly.
I'll speak a bit louder.
My
Is this
internet,
better?
yes, ma'am.
Okay. So, can you repeat again what you said about type 2 error?
Type 2 errors is you reject the alternative hypothesis. Like you reject you reject the null hypothesis when it is false.
So, I'm rejecting the null hypothesis, and the null hypothesis is false. How is that a bad thing? How is that an error? It should be a good thing that I'm rejecting something which is not true.
Sorry, ma'am. Null hypothesis is true, but you rejected the null hypothesis.
Isn't that type 1 error? Probability of rejecting H naught when H naught is true. Think about it for a moment. Recollect in your mind and then tell me. You wrote type 1 error, right? That's what it means. Probability under H naught that X curl belongs to the rejection region. So you're rejecting H naught when H naught is actually true. So what is type 2 error? What can be another type of error that can happen? One is when H naught is true and you're rejecting it. What if H1 is true? Then what can be an error?
When H naught is full, you cannot escape it.
When okay, so you said type 1 error is rejecting H naught when H naught is true. So what happens if we accept H naught when H naught is not true?
I call that H naught is true, but you can reject it.
But that is just type 1 error, right? Raghav, am I making a mistake?
Sorry, I was not listening. Let me see. So,
Uh,
reject H naught, rejection region when H naught is true, that is type 1 error.
so yes. So I'm asking what is type 2 error, Devjyoti? Let's say that H naught is H naught is
Except H naught when it is false,
okay.
right?
So, but I guess what he said is type 1 error in both cases. Maybe I misheard. Okay, let's go to the next question. So, what is power of a test, Devjyoti?
It is a power. Power is a when you H naught is false. When
Hmm.
when you rejected the H naught when H1 is true.
You said H naught is false, and then you reject H naught when H naught is true.
H1 is true.
Okay. Okay. So, what is a biased test?
Biased. Limit n tends to infinity. Power is equal to
Is the limit necessary?
you can take the last sample.
I don't think large sample is required to check for biasness of a test. I'll give you a hint. So a test is called biased if a certain inequality between power and size holds. Can you tell me what the inequality is?
Unbiased, when a test is unbiased and power is equal to size. When it is
Can
biased.
power be equal to size? So let's say I have a test for which size is 0.048 and power is also 0.048. So you're saying that is an unbiased test. Okay, I'll tell you. A test is called biased when the power is greater than the size. So size is what is size?
Size is type 1 error is size. Type 1 error is size and simple hypothesis under each one.
Okay. So the size of a test, when it is smaller than the power, then we call it a bias test. So the power should be as big as possible, right? When something is false, we should be rejecting it with a higher probability. That is how power is defined. How powerful a test is how frequently it is rejecting a false hypothesis. So power should be greater than size for a for a unbiased test. Okay, so a biased test is when the opposite happens. Do you get me?
Yes, ma'am.
So power is greater than size, then it is an unbiased test. So can you give me an example of a biased test where power is less than size?
No, ma'am. Do not remind me this moment.
Okay, I'll give you a hint. Just rub the board. Say x1 up to xn follows IID normal mu comma 1. H naught is mu equal to 0. And H1 is mu greater than 0. Okay. So for simplicity, we take just one sample point. So my test is I reject H naught when x is less than 0. Okay, and I only have x1. Write it down. So my psi x or phi x is 1 when x is less than 0. 0 otherwise. Now calculate the size and power of this test. We only have x1, okay? What did you calculate?
Here is mu is 0 under H naught.
You should
So
write that because it's important to write that it is under H naught. This is probability under H naught, x is less than 0. Okay, that is half. Under H naught, why is it half? How could you directly write half?
you can standardize it. Probability under H naught x minus 0 by 1 minus x over 0 by 1.
Okay, it's half. And what about the power? What did you write? Probability minus mu. So mu is greater than 0. So psi minus u is less than half. Can you hear me? Am I audible?
Yes, ma'am.
Okay. So could you say that this is an unbiased test or biased test?
Size, you can say that the size less than power, so it is a biased test.
Size
But
is
greater than.
okay. Okay. I'm done with my questions. Raghav, you can stop recording.
Thank you, Devjyoti. Diwakar sir will answer your queries in a minute.